In this video, we're going to discuss wheel and axle, and by the end of the video, you should be able to know what wheel and axle is all about and how to solve questions relating to wheel and axle. So let's look at this diagram. This is wheel and axle. It consists of a wheel with a groove where the rope is attached to the path of effort where it's going to be drawn. All right. And this rope here also connects to an axle, just a cylinder attached to this that is free to rotate. Okay. So when you turn this wheel rotates and causes this axle to also rotate. All right. And this rope, as you can see, extends to the axle. So when you pull this down, it turns this and turns this axle, causing it to lift this load to move upward. So it causes this load to move upward, jacking this load up. So that is what wheel and axle is. So next we're going to look at the velocity ratio of wheel and axle. Velocity ratio is distance moved by effort to the distance moved by load. All right, so let's look at the effort part of this. The effort is applied to the wheel, which is the bigger cycle, and it's going to turn it through one revolution, and that gives us 2 pi r for the circumference, because it's going to turn one revolution actually describes a circumference here. Then the load is attached to the axle. One revolution in the axle is going to be 2 pi r, small r because the radius is small letter r. And that gives us velocity ratio to be r over r. This 2 pi goes with this 2 pi. So the velocity ratio for wheel and axle is the ratio of the radii. Let's go to the example. Wheel and axle has a wheel radius of 40 cm. Wheel radius of 40 cm. So that is capital letter R, 40 centimeters. Okay, and an axle radius of 8 cm. That is small letter r, which is 8 cm. All right. If an effort of 50 newton, so we're also giving effort. We're giving effort to be 50 newton is applied to the wheel to lift a load of 200 newton. So we'll have load which is 200 newton. Okay, calculate the mechanical advantage of the machine. So first is mechanical advantage. MA equals load over what? Effort, as we have established. Mechanical advantage ratio of load to effort, and our load is 200 upon effort is 50. All right, this goes with this, so this will give us 4. Of course, there is no unit to that because this is in newton, this is in newton, and newton will cancel newton. So our mechanical advantage is 4. So the answer to this is 4. Let's go to the B part of the question, which says the velocity ratio. Velocity ratio, as we have established, is the ratio of big R to small r. So we're going to say R upon R. Then big R, which is the radius of the wheel, is 40 cm. The small r, radius of the axle, is 8 cm. So this cm goes with this cm. 8 in 40 gives us 5. Again, there is no unit for velocity ratio because cm has cancelled centimeters. So let's look at the efficiency. So efficiency, as we know, is mechanical advantage over velocity ratio multiplied by 100%. All right. So efficiency, on substitution, we have gotten our mechanical advantage to be 4. Velocity ratio is 5. So half over 5 multiplied by 100% over 1. This 5 here, 5 in 100 gives us 20. So half 4 times 20, which is 80%. So this machine is 80% efficient. We'll move to the next question. So this is the second example we're going to look at. It says the efficiency of a wheel and axle is 100%, and the ratio of their radii is 5:1. Calculate the effort required to lift a load of mass 20 kg using this machine. And these are the options given to us. So quickly, we're going to solve that. Solution. Let's write out what we have. We are given efficiency as 100%, all right? And the ratio of the radii, which is the velocity ratio, VR, which is r to small r, is 5/1, which is going to be 5. So velocity ratio is 5. Okay, required to lift a load of mass. We are given the mass of the load. So the load itself is going to be m times g. G is 10. When you times mass and g, that gives you the weight, and that is the load. So we're going to have, what is mass? 20 multiplied by 10. That gives us 200 Newton. So the load is 200 Newton, okay? Now, recall that efficiency is mechanical advantage over velocity ratio multiplied by 100%. On substitution, efficiency is given to us as 100%, which equals ma over velocity ratio here is 5, then multiplied by 100%. Now, this percentage here can go with this 100 goes with this. So we're going to have 1 equals ma over 5. When I cross and multiply this over 1, I'm going to have mechanical advantage to be equal to 5. So the mechanical advantage is equal to 5, and with that we'll be able to get the effort, because we know that mechanical advantage is the ratio of load to the effort. All right, on substitution, ma, we have gotten it to be 5. So 5 equals load. Load is 200 Newton. That is 200 over effort. Okay, when I make effort subject of formula, effort will be 200 over 5. Okay, and that gives me 40 Newton. All right, and that is option C. So option C is correct. The effort required is 40 Newton. You can see.